Hey guys, welcome back to a new video. In this video, I will rank the 5 most common state management approaches in Jetpack Compose from S tier, which will be the best, down to F tier, which will be the worst. And we really don't need to make these approaches here secret. I will talk about remember immutable state off. I will talk about the MVI pattern with a state data class, mutable state flows. I will talk about combined flows, sealed state, so a sealed class as your UI state, and separate state flows, which is more the MVVM-like approach. And of course, I won't just rank these, but give you clear reasons why I'm actually thinking that way, what the benefits and downsides of these approaches are, so that afterwards you will have a much better understanding of Compose state management. And by the way, right now, when you're watching this until Sunday, you can still get 30% discount on my brand new Kotlin Beyond Syntax course with over 200 lessons on Kotlin language features, where we really also deep dive into generated bytecode and everything that belongs to Kotlin. But you also get those 30% on all other courses and bundles. Link is below. The discount is already applied in checkout. Happy learning. So let's first of all take a look at using remember along with mutable state off in Jetpack Compose. This one gets a solid F tier from my side. So this is literally the worst state management approach that you can pick in Compose apps. Why is this so bad? Thing is, even if you already do something right and you bundle your Compose states here at the absolute root of your screen, and therefore you stick to the principle called state hoisting, that you just pass these states down and then bubble events up, like when we click on a loading button, and then just mutate the state that you still hoisted outside of this child composable, for example. That's already good, but it does not make this approach much better. There are two big downsides. On the one hand, just using the normal remember function here will make sure to remember these states here across recompositions, but it will completely kill the state the moment there is some sort of configuration change, like a screen rotation, switching the device theme, or of course process death, so when your app is in the background and the system kills it, and the user then comes back to it. We can also see this here, so I have the same scenario for this UI here for all these different state samples. If we click on load data, we will see a loading state, this one gets disabled, and then we see a bunch of items, or based on random value, it would show a simulated error message. So now that we have loaded our data, if we actually rotate our device, then it's lost again. So we get back to this overview of state management approaches. This is simply the big downside this approach with remember and mutable state has. Yes, we can fix that by using remember savable, which will actually persist those values across recompositions and even across process death. But on the one hand, your state also needs to be serializable. That is a requirement of savable. And the moment you have some sort of more complex type of value that you store here, that doesn't work anymore. And even with that approach, this remember or remember savable and mutable state of approach has a second very big downside, and that is that your entire state logic, so the logic that decides when and how to update your state, is inside your composable functions. So you can see, the moment you actually want to change a state, then you need to do so in certain lambdas, where we then launch a coroutine scope, have some real, technically business logic that you put here inside your composable function, and this not only becomes very unclear over time because you're mixing responsibilities, you're mixing state update logic with displaying UI and interpreting that state. And the moment you actually want to write some test cases for this logic, you would have to spin up a real UI test. So you would first of all have to make the test case build an APK, it has to be installed on a real Android device, then the UI tree has to be simulated, then real user actions like button clicks or swipe to refresh have to be simulated so that the code here really triggers, and the assertions that you then run on this don't just run on a specific Boolean condition here, for example, but they also, again, have to be run on the actual UI. Of course, there is a place for UI tests, but everything that doesn't need to spin up a whole UI test, like testing this plain logic here, would then need one if that logic is in the UI and not in a plain Kotlin class, for example. So definitely the worst approach you can pick here. Coming to the typical MVI approach, or what most Android developers actually understand of the MVI architectural pattern, here we have actually just one single state, so here this MVI screen state, for example, where all these different fields that could change over time and have an impact on our UI are in the end bundled in a single data class that is then exposed to our UI. So while previously with our remember approach, every single state here was a single field in our UI, here we now have one single state that is in the end just a class and bundles all these single fields inside it. So we have items, loading, and error message all in the single class. And of course, if your screen grows, this would be a quite bigger class. On the other hand, for everything the user can do on the screen, like tapping a button, swipe to refresh again, all these typical callbacks you would get from your UI components, for that, we model that typically via such a sealed interface by just bundling all these actions, all these things that a user could trigger on a screen inside a sealed interface. And I typically call these action. So to-do action, for example, for the to-do list screen. So here it would be retrying the request or clicking on loading data. And this state is then managed in a real view model. So in a separate component, in a separate class, that will survive screen rotations and also allows you to make certain fields survive process death via safe state handle. But in here, you can now see how this looks like. So we have a single state that is implemented in form of a mutable state flow. Could technically also be a compose state, but I would recommend a mutable state flow. It's a bit more flexible. And this single state is then contains an instance of this MVI screen state in this case, and has then this exposed immutable variant that the UI will consume. On the other hand, it exposes a single public function on action, which then receives these callbacks from the UI, like when tapping retry or loading data. And if we then take a look at our screen, this is how it looks like. So we have our state that we observe from the view model. We pass this down to our actual screen content, so the actual real UI. And for all actions, we simply directly forward them to our view model here in form of one single Lambda expression. This state management approach for Compose apps goes straight to the S tier, and I will explain why. That is, however, under the assumption that it is applied correctly. On the one hand, a big advantage is that your UI will stay really clean, because regardless of how large your screen is going to get, your screen composable will always just receive a single state field and a single on-action Lambda, since all single actions and all single fields powered of that state are bundled in either this class or the sealed interface. And therefore, even if your screen grows very complex and gets maybe 20 different fields that could change and have an impact on the UI, well, then you just add these here to the state, but that doesn't change anything about what the UI receives. It still receives an instance of the state. The only little downside that I would accept here is that, of course, this boilerplate that you save here in the UI, you add a little bit to your state and view model. So, of course, every single action that you add requires a new line here. Every new state you add requires a new line here, and a new line here in your when expression in this view model to just decide which function from the view model to call when a certain callback from the UI was received. But somewhere you actually have to put those, so this is definitely something that you can't really bypass. However, I need to share some tips here on this MVI pattern and applying it correctly, because if you don't apply it correctly, it's not really a good pattern. On the one hand, the moment you update your state, this is, as you can see, typically done with copying the instance of that current state to just make an immutable copy while changing certain fields. That always has to be done with state update, because otherwise you may run into race conditions that this copy call could lead to if two different threads actually make a copy of the state at the same time and then mutate it at different times. Also, something you have to be really careful with is that you don't pass down this state, so the entire state instance, to child composables here. So the screen, the absolute root composable, can receive that, but don't take this and pass this to a child composable that maybe only needs some parts of that state, because otherwise, every single time anything of that state changes, that child composable will recompose, even though it may not have to recompose. But if you stick to that, solid S tier. Coming to the third approach, which is the traditional MVVM pattern, which is legendary in Android development. MVVM for Jetpack Compose goes to the A tier, in my opinion. And I will, of course, explain why I think that way. The differences here in comparison to MVI, what we've just seen, are typically that MVVM treats every single state field here in a view model, so it also uses a view model, it treats them as a separate state, so a separate state flow. Here we don't have a single state flow anymore that just keeps a data class that bundles item, loading, error message, and so on. But all of these here are actually separate state flows. Additionally, MVVM also doesn't work with this on-action function here, which is the reducer in the MVI pattern, where it receives some kind of sealed interface instance and then reduces that to some kind of function call here in this view model, but instead exposes public functions here that the UI can call directly. Taking a look at the UI then, you can see we have to then listen to all these different state fields here individually with collect as state with lifecycle, and then also pass these down here individually, as well as bubbling up every single user action here from the UI to the view model and calling the right function that way. Well, what are the advantages of MVVM here? Well, just like with MVI, we're using a view model, so it comes with all the advantages regarding surviving configuration changes, surviving process death. You can at least implement it in a way that it survives process death. By default, like it's implemented right here, it also wouldn't survive process death. That is easily possible in a view model. And a big benefit of the MVVM pattern is that you have all your single fields here available as an observable state flow. So this means you're also very flexible in combining different states here and also deriving new states of that. So for example, if you wanted to do something whenever either there is a new list of items or there is a new state of this is loading boolean, well, then you could also derive another state flow of that. So other state, where you say, okay, you combine two different states. On the one hand, these items, and on the other hand, this is loading Boolean. And then you say, okay, you get those items and is loading in here. And this block would then fire whenever any of these changes. And you can actually map this to a different kind of state that is then dependent on the new values of items and loading. This is, of course, something you can do out of the box here with MVVM, since you have all those fields available as separate state flows. While with MVVM, we just have that single state where all of our subfields are kind of baked into in that data class instance. You can also do this with MVI, but it requires a separate mapping step, a separate step here in this flow pipeline. So you could, of course, go to MVI, to your MVI view model, and you could then say you have your private value, you have your is loading flow, and you simply derive that from your state by mapping its value to just the is loading value, and then either also saying state in or distinct until changed. And then whatever follows here will really only trigger when this is loading changes. You can still achieve the same with MVI, but it's a bit more boilerplate code than with MVVM, since here you already have these fields ready out of the box. And normally I would also give MVVM here a real S tier, but the reason I give it an A tier, this is really just because I don't like it too much when used with Compose, because this here will really lead to a whole lot of boilerplate code. This is still a super simple screen that we have here with just 3 values that can change, but I've really worked on apps that have 15, 20, 25 such values that can change. And then your first 200-300 lines of your model can quickly become just managing state or defining state. And not just here, but also in your UI, all these single fields will then have to be passed down to your actual screen composable, as well as all these single lambdas have to be passed up here to make these events bubble up to the view model. So if you have 20 different fields that can change, your composable will also get 20 such parameters. And this is really what I don't like too much here in the context of Jetpack Compose. Back then, when we were still using fragments, this was still a little bit different. There, I would have given MVVM a solid S tier, but here for Compose, it's just an A tier, but it's still a solid pattern. Coming to the fourth pattern here, and that is using a sealed class in order to model your state. So specifically, the state will look like this here, a sealed class, and then you have all those different mutually exclusive states, that is an important part here, that your UI could end up in. So an idle state, a loading state, a success state together with the items that have been loaded, and an error state with the message based on what actually happened. This approach I would put to the C tier. So let's take a closer look at how this works in the UI and view model, and then I'll go over my reasons. In the view model, we then also just have a single state that we expose to the UI, similar as with MVI, just that this state is now one value, one child instance of this sealed class. And therefore here in our load data function, we can then say, okay, now we're actually loading data. If something failed, we're putting this to an error state. And if something succeeded, well, then we just put all those items we've loaded here and put that into the success state. And well, in our UI, we then simply have such a when expression that goes over what the state is and then has really clear when branches here where you can see, okay, in the idle state, our UI looks like this. In the loading state, it looks like this. In the error state, like this. And finally, the success state, it looks like this. And this is already one of the few benefits that I see in this approach. You get this when exhaustiveness, so that this when expression just forces you to have clear branches and clear values for all kinds of valid instances this state can take. And if you forget one of these, well, then it will actually tell you about that the when branch is not exhaustive, and you need to also keep track of the idle case. However, this is really a state management approach you cannot blindly apply to any kind of screen, which is why I really put this to C tier. The thing is, what this assumes is that all these states here are mutually exclusive. So this means there is never a scenario where two of those states are true at the same time. And here in this simple example, it makes sense. So we're never in the success and error state at the same time. We either have an error or a success state. So this can, on the one hand, be an advantage because you cannot even end up in such a scenario where you, for example, show a loading spinner and a list of items, because that is an invalid state, and you avoid this by design here with this approach. But the thing is, it's not that applicable in any kind of scenario, or you will make the sealed screen state here explode. Because what if you actually have a little bit more complex screen and you cannot actually just load one piece of data, but actually 3 different types of data? So let's say you have a call that loads the settings, you have a call that loads some list of users, and you have a call that loads your own profile. And all these calls can actually happen at exactly the same time. They are in fact combinable. You can load both settings, users, and the profile at the same time. So how do you do that? Well, you cannot simply say, okay, you duplicate this, you say loading users, loading, what was that, settings, and this here would be loading profile, because doing it like that would assume that you can either load the profile or the users or the settings, but not all of them together. What you could also think of is, okay, you actually have just a single loading state where you say, okay, you have a data class, single loading state, and here you then say, is loading users, and then you also have all these other states, is loading settings, and is loading profile. And then you could say, okay, I'm now in the loading state, and the UI can check, okay, which of these is actually loading. But well, then my question would be, couldn't it be that the profile has already been loaded successfully while the users and settings are still loading? With this approach, you would not be able to move the profile into a success state while still having the other states here loading. So technically, if you wanted to consistently stick to the state management approach, you would need to model every single kind of valid combination that your state can take as a single child class or object here of this sealed state. And that will just break at some point. So you can apply this to simple screens where it's super obvious and super clear that there are different mutually exclusive states. But anything more complex, this will really not be a great approach. Also, a downside is if you actually are in, let's say, the success or error state, and it consists of more than just one field, if you want to change just one single field, part of that existing success state, then you would actually need a type check in order to check, is that actually, am I currently in the success state? And only then you will get the smart casting capability from Kotlin to create a copy of this state in order to just change a single field and not create a whole new instance of this class. So all in all, not that great. I'm really not a friend of this approach. Coming to the last approach here, which is called combining state flows. I don't know if this approach has a name, but in the end, it's kind of a hybrid between MVI and MVVM. So here's our UI. We also have our screen. We have a view model. We observe a single state from the view model and just pass this down here to our UI, just like with the MVI example. So here's our state, also just a data class that bundles all these fields. Here, by the way, we can combine them flexibly since they are all put in a single data class in comparison to the previous approach. But the interesting part now comes here in our view model, because with this approach, we actually work with single state fields here, just like with MVVM, but we only keep them as mutable state flows as private properties inside the view model. We don't expose all these single fields here as a public state flow. But what we do is we expose a single state that is then put into a data class by combining all these different states here inside this view model. So in the end, we have those private state flows that we can flexibly update here from anywhere in the view model. So we can set loading to true, we can reset the error message, we can then set the error message to something, and of course also set the items to something. But the moment any of those fields changes, our combine block will trigger, because again, remember, whenever any of those past state flows here will emit a new value, will change, then this block here will trigger and combine or merge all these states together into our state data class that is then finally exposed to the UI. So this means when our isLoading, for example, switches from false to true, then, well, since that is part of our combine block, this will emit a new value with the most up-to-date items, with the most up-to-date isLoading boolean, so the new true value, and the most up-to-date error message, and it will create a completely new instance with all those most up-to-date values that the UI will then receive and can then pass down as a single state without having to pass down all these different state field values as with MVVM. This approach goes straight to the A tier. I kind of like this approach. It's actually a good idea. It also, by design, gets rid of race conditions, which this combine block here takes care of, since you don't rely or have to rely on updating a state flow with state update and then creating a copy, because here no real copies are created. We only update single fields and set them to a value, but this value is not dependent on some kind of previous value you create a copy of. This also limits boilerplate code in comparison to MVVM, since you only need the private values here for these state flows. Well, on the other hand, you of course also need this data class that these are then combined into. But all in all, I would still say this is less boilerplate heavy as MVVM, since also on the UI side, you can just pass down the single state field. So regardless of how large this grows, your UI composable will stay pretty clean. And you actually get derived state for free with this approach, which is pretty cool. So this means this state here is in the end derived from one of those values, actually from all of those values. And whenever any of those values changes, wherever that happens in this view model, you don't have to take care of that. You automatically get the full, complete, and correct state here as a result of this combine block. Why am I not putting this to S tier, but just an A tier? Well, again, because things get a bit tricky when your view model grows. Because if we take a look here in this combine function, then at some point, specifically after passing the 5th state flow, so when passing the 6th one and more, it will jump to this overload that takes in a var arg. So in theory, you can pass as many state flows here to this combine block as you want. But the moment that happens, you will actually not get these as single fields here in the lambda function, but you will get those as an array. So the moment we would actually exceed this amount here and have 6 fields, we wouldn't be able to just easily access them here, but we would get all those states as a single array. So an array of anything that could be nullable. So you not only need to unwrap and access all those fields, so you would have the items list here coming from states at the index of 0, you would not only have to kind of destructure this array into clear fields again, but also have to have typecasts to say you convert this to a list of, what is that list item? Something, I don't know if that's this. But in the end, you need these typecasts for all these different items again in order to then pass these down here. Then it will work, but this approach and doing it like that doesn't feel that well anymore. Technically, what you can, of course, also do is, let's revert that very quickly. What you can, of course, also do is you can write your own combine functions that simply allow you to accept more than these 3 flows, or more than 5 flows it was. So you could technically specify your own combine overload that takes up to 20 different state flows, but you would then also have to provide some that take 19, some that provide 18, 17, and so on. I think there are actually libraries that also come with that. This would make it a bit more convenient, but it always stays a kind of a limitation of this approach, because you also never know how many of those custom combine functions do you need, because the moment you would have one view model in your project that would exceed this amount that you've specified yourself, you would again have to implement more. And this will then become quite a lot of boilerplate code. So my go-to pattern for Jetpack Compose is and remains MVI. I use that in all my courses, and if you want to get some of these courses, now is a very good chance to do so. Oh, that was a transition. 30% off, as I mentioned, link is down below, only until Sunday, then all the prices will rise again. So if you've been thinking about getting some of these already, now is really the time. Not just courses, but also bundles. They are already discounted and are now discounted by even more, 30%. Check it out, happy learning, and then I will see you back in the next video. Have an amazing rest of your week. Bye-bye.